Alright, welcome to chapter 14, guys. We are in 14.1 talking about the polygon angle sum theorems. Now, one of our students in summer school class alluded to how this actually works. What we decide is that any polygon, what mathematicians more so have figured out, is any polygon can be broken up into triangles. And how many triangles is really n minus 2, where n comes from the number of sides. So this is our theorem 38. It's called the polygon angle sum theorem, and I decided we would use a septagon here, a nice seven-sided shape, to look at this. So the sum of the measures of the interior angles of an n-gon, in our case we're going to have a 7-gon. So let's just go ahead and say a 7-gon is n minus 2 times 180, because we know every triangle has 180 degrees in the interior. So I'm going to pause this for a moment and come back with this broken up into triangles. So we see that when I break up this septagon, I end up with 5 triangles, 7 minus 2, and each of these triangles would have 180 degrees. Now some people will think incorrectly, but we don't use all the degrees. We actually do, because when I look at all these corners, at all the vertexes, this angle and this angle are both used to create the angle of the septagon. This angle is one of the septagon angles. This angle, and this angle are all needed to create the angle for the septagon. So as we go around, we actually see we do use every single angle of the triangles, which would mean that the interior angles of my septagon would just be 7 minus 2, or 5 times 180 degrees. Work through the first problem in the Pearson module. Come back when you think you have the answers for the got it, or when you need help on the got it. Alright, for both of these situations in the got it, all we're going to do is use our formula. So for A, to find the measure of a 17-gon, we just set up our formula, and n is determined by the number of sides on your polygon. So here it's 17. So we plug in 17 for our n, and we do 17 minus 2 equals 180. So then my 17 becomes a 15 times 180, which gives me 2,700 degrees as our answer. Now in B, we want to use the formula again, but what we're told is that the sum of the angles is 1980, or 1,980. So we set up our formula with n as our variable, what we're trying to solve. We would divide on both sides by 180, giving us just n minus 2 left on the left side and 11 on the right side. I then add 2 to both sides and find that that must be a 13-gon. Use your formula to solve for these, and yes, you can just use a calculator. You don't really have much work to write out. Remember that your formula is n minus 2 times 180. So hopefully here for number 1, you got 5,940, and for number 2, you got 3,240. So let's review our special polygons. An equilateral polygon, remember lateral means the lengths of the sides, so that means all of the sides of the polygon are the same. Equiangular polygon tells me that all of our angles are congruent, and a regular polygon means that all the sides are congruent and all the angles are congruent. So the traditional like hexagons, octagons that you're used to seeing, those are regular polygons. Like a stop sign is a good example of a regular polygon. So then a corollary to our polygon angle sum theorem is that if we have a regular, pay attention, regular, it's got to have all equal sides and all equal angles, a regular polygon, we would just average the sum of the angles to find each individual angle. So we would take the sum of the angles and then divide by the number of angles to get an average, and that would give us each individual angle. Please make sure that you've worked through the Pearson module for this problem. An important thing to know is what a non-gon is, or nonagon, which means that it has 9 sides. So go ahead and do the math. Come back here when you think you have the answer. Alright, the first thing we need to do is figure out what the total angle measure for this shape is. So since it's a 9-sided shape, I set up my formula where I have 9 minus 2 times 180. That would give me 1,260. After that, I want to average that total angle measure to each angle. So I take my 1260 and I divide by 9, because there are 9 angles. That gives me 140. So that tells me that each interior angle measures 140 degrees in that regular nonagon. So I know it's a little difficult to see on the video here, and it's harder probably to see in your notes because I went ahead and outlined these in a darker color. So what you have here in number 3 is a 12-gon, and in number 4 you have a pentagon. Let's go ahead and try to figure out the measure of each or one interior angle of these regular polygons. Pause the video, come back when you think you have your answers. Alright, for number 3, since we have a 12-gon, we go ahead and set up our formula where we have 12 minus 2 times 180, and that gets me 1,800 for my total degrees. I then take my 1,800, divide by how many sides we have, and that gives me a final answer of 150 degrees for each interior angle. Likewise, on number 4, we start with a pentagon, so we set up my equation 5 minus 2 times 180, which gives me 540 for the total interior angles. Then I take my total degree measure, divide by the number of sides, and I get 108 for my final degree measure of one interior angle. Now I want to caution you guys, if you are doing this just in your calculator and you're immediately thinking of taking the n and subtracting 2, the common mistake I'll see here, like in 3, you would have thought 10 times 180. But then the mistake that I see often is they'll divide by 10, since that's the number they were thinking of, instead of the actual number of sides for the polygon. So just be very careful with that. So if you've made it up to this got it, go ahead and pause the video and solve it on your own. We have a quadrilateral here, which means it is a 4-gon. So you want to start by figuring out what is the total sum of all the angles, and then find your unknown angle based off of that. So pause the video, come back when you are ready. Alright, so we start by finding the sum of my interior angles, which if you cannot remember, a quadrilateral sums to 360 degrees. Just like a square has 4 90-degree angles, even though these are not 90s, they still have the same sum because it has 4 sides. Then I can use substitution to say, okay, well, my 4 angles will add up to that 360, and I can combine my like terms. Then I can use algebra to subtract 258 from both sides and find out that my angle G must equal 102 degrees. Try number 5 and 6 to do the same thing. 5 is pretty easy since you already know that the sum of these will be 360, but 6 you need to count your sides and figure out the sum to begin with before you can solve it. Alright, so for number 5, we have H, 2H, and 2H, so a total combined of 6 H's, and they sum to our 360 degrees. And when I divide by H, I find that H is 60, so both of these angles would be 60 degrees, and both of these angles would be 120 degrees. Now over here in problem 6, we have to start by counting how many sides we have on our polygon. We see that it is a 7-gon, so we can set up our formula 7 minus 2 times 180 and find that the sum of all of our angles equals 900. So now it's time to substitute. So we are going to set up that the sum of our angles equals 900, and I went ahead and added up all of the angles that I've highlighted in yellow, and those add up to 755 because I did not want to type them all out. You can just plug those into a calculator. And then I use algebra to solve my equation down here to get rid of the 755 from both sides. I just subtract it and find out that y is equal to 145 degrees. So here's another interesting theorem about our polygons. We now know how to discuss the interior angles of a polygon, but what about the exterior angles? So we know that we can always extend our lines to form exterior angles, but one thing to pay attention to here is at this angle, so at my angle of 100, whether I extend the line the way that they have shown, or whether I extend the line the other direction, both of these resulting exterior angles would be 80 degrees, because they both are a supplement with 100 and they're vertical to each other. So it doesn't matter which line we extend, as long as we extend one line at an angle, we can find its exterior angle. Same thing over here, we have 115 in this angle as well. So now let's look at what this theorem tells me. So before we jump down to the theorem, I'll take another second, I guess, and show you. If I look at this 80, this 150, and this 130, one exterior angle at each vertex, they add up to 360. On the quadrilateral, the same rule holds. I've got 115, 75, 71, and 99. They all sum to 360. So the pattern that we start to see is how we get to theorem 39. The sum of the measures of the exterior angles of a polygon, when I highlight this in a different color, one at each vertex. So you can't start taking multiple exterior angles at a single vertex. We have to have one at each vertex. They will always sum to 360 degrees. So please make sure you've worked through the Pearson module to make it up to this got it. What we see is we want to find the measure of an exterior angle of a regular nonagon. So we know that a nonagon is a 9-sided shape, and we know that any shape exterior angles sum to 360, so we can just take the sum of all the angles and then divide it by 9, because we know that it's a regular nonagon, which tells me since it's regular, all of my angles will be the same, which is why I'm allowed to divide and just essentially find an average. So when I divide 360 by 9, I will get 40 degrees. And then go ahead and move on to 7 and 8. Pause the video until you have the answers to these. You again want to find an exterior angle on these regular polygons. You know, all the exterior angles will be congruent to each other. So remember, what we start with on all of these is that the sum of my exterior angles will be 360. Then I want to divide by how many angles I have, which will be 36 in a 36gon, which gives me 10 degrees for problem 7, and likewise the process gives me 3.6 for number 8. Alright, we're going to wrap up the lesson with these 3 problems, so please pause the video, solve all 3 of them, and come back to verify your answers. Alright, number 9 starts by asking us what is the sum of the interior angle measures of an 11gon. So we just set up our polygon angle sum formula. So we use the number of sides minus 2 times 180, which gives me 1,620. But then in 10, we're being asked what is the sum of the exterior angles of a 15gon. Now a 15gon doesn't matter because the sum of any polygon's exterior angles is always 360. So that was kind of a trick question. Doesn't matter what kind of gon. It could be a 1,700 gon and they would still sum to 360 degrees. 11 is asking me to find the measures of an interior angle, an exterior angle, and in a regular decagon. So remember, regular means that they're all the same. So we start by saying our triangle angle sum formula for the interior angles, they sum to 1,440. Then I can divide by 10 since I know that all of the angles will be congruent, and I get 144. Now I know to find the exterior angle that the exterior angles are supplementary to the interiors, so I could either find that being 36 based off addition with 144 to equal 180, or we just use our formula of 360 divided by 10 to get 36 degrees. That is all that I have for you guys in this lesson. So that is just the beginning of chapter 14. So please keep me tuned in if you guys are having any issues or struggles so that I can get you help as soon as possible. Please do the practice, and I will see you guys in class. Have a great day.